Imagine for a moment that you are running a high-speed coffee shop, processing hundreds of mobile orders every single hour. Every time a customer taps buy on their phone, they generate a burst of information. You have to track their name, the specific drink, the exact price, and a timestamp for the transaction. If you try to write all of this down in a paper ledger, you will fall behind in minutes. Even a basic computer spreadsheet will hit a wall as the orders keep piling up. Once you reach tens of thousands of rows, these standard files start to lag. Eventually, the software freezes or crashes, potentially losing your sales records because it lacks the power to handle industrial-scale information. At this scale, the business depends on an unbreakable system to organize the heavy, invisible flow of data behind every single cup. That heavy-duty container is called a database. It is software specifically engineered to hold massive amounts of data securely without slowing down. Databases organize information into strict, neat grids called tables. Every piece of data has a protected slot. But unlike a spreadsheet, you cannot use a mouse to click and scroll. The structure is impenetrable to standard tools. To retrieve information, you have to use a specific language called SQL, or Structured Query Language. Despite its reputation as coding, SQL requires zero math. It functions like placing a food order by filling in 3 specific blanks in a sentence. Suppose you need to answer an urgent question. Who exactly ordered an iced latte in the last hour? To ask the database for that answer, we use a standard formula with 3 core commands: select, from, and where. This exact fill-in-the-blank structure is the foundational building block for talking to almost any modern database on Earth. By filling in these 3 blanks, you gain the ability to directly command the database yourself. We start with the first command, select. This asks the database exactly which columns of information we want to see. In our coffee shop table, we only need to look at the customer name and drink type columns. We plug those names into the first line, so it reads, select name, drink. Next is the from command. Since a database can hold many different tables, we have to point it toward our specific orders table. We fill in the second blank with the table name, so the command reads, from orders. With just 2 lines, we have successfully located the exact filing cabinet and folders we need. Now we can apply a filter. If we stop now, the database will return every single order ever placed. To get a specific answer, we use the where command. Think of the where clause as the ultimate filter. It narrows down millions of rows to only the ones that match your precise condition. Since we only want the lattes, we fill in the final blank with our condition, where drink equals iced latte. The completed sentence reads, select name and drink from the orders table where the drink is an iced latte. When we run this query, that giant table collapses instantly. The database ignores the noise and leaves us with only the exact rows we requested. This filtering action is the source of SQL's power. It takes a massive ocean of raw information and provides a precise signal. You just mentally wrote and executed a piece of functional, real-world SQL code. While professional developers use SQL for complex math or to combine dozens of tables, this 3-part formula remains the foundation for everything they do. When you search for an action movie on a streaming service or filter by size on a shopping site, you are using a visual interface that writes this exact SQL formula in the background. Every time you click a digital filter online, you now understand the exact logic the computer is executing to find your data.